Imagine a cutting-edge AI data center, bustling with activities. Rows of servers hum with power, processing vast amounts of data to train the latest AI models. In this high-stakes environment, every millisecond counts, and the choice of cabling and connectivity can make or break the performance of AI workloads. As AI workloads continue to grow in complexity and size, ensuring reliable, high-speed data transmission becomes crucial. In this video, we will take you through the essentials of AI transport, highlighting the key technologies and practices that ensure optimal performance, reliability, and scalability in AI data centers. So when we need to connect those different devices in an AI-enabled data center, we need to just cable them together. We need to connect them using different kinds of cables. But hey, it's not just about an AI-enabled data center. It's about any kind of network, right? So you want to learn about your cables. You want to be very specific about what kind of cable you're trying to use within your network, whether this is a fiber cable, a fiber media, or a copper media, whether this is an Ethernet technology or an InfiniBand technology, because both those technology giants, they provide you with those different flavors of cables, whether this is copper or fiber. So let's start with the most famous one here, which is your UTP cable. UTP, okay, unshielded twisted pair, and this is from Ethernet. This is the copper kind of cable, which is the most common one that we all know about. 8 different singular wires or 4 different pairs, and they're color coded. So I'm not going to dive deeper into the nitty-gritty details of the colors and how it actually has the crossover cable and the straight through cable. But hey, we know for sure that Ethernet is a technology that provides copper media and bandwidth that we should be thinking, something that you should think about when you're trying to design your AI data center is the bandwidth. What is the maximum supported bandwidth when it comes to UTP? Well, guess what? We have 10 gigabit per second, 10 gigabit per second, which is good. But hey, what if you needed more bandwidth? What if you needed higher speed? Then, well, I might kick it up a notch and then move to fiber. So when I say fiber, Ethernet is not going to leave you behind. They also offer you the fiber optics. But hey, when it comes to fiber, it's not just about the cable. There are other bunch of things that come along with the cable. So for example, you will first need the optical transceivers right here. I see the SFPs right here. Okay, these transceivers, what do? As you know, it converts the electrical signal into optical signal and vice versa, enabling data transmission over those optical cables. They consist of 2 main parts: the sender, the transmitter, TX, and then something is going to be receiving on the other end, which is the RX, the receiver. Take OSFP as an example, the octal SFP, small form factor pluggable. Okay, that will support, as you see here, okay, that's quite a bandwidth. It can support up to 800 gigabit per second. That's not it. And also worth mentioning that you will need to use optical connectors like LCs or SCs, lucent connectors or standard connectors, and also high speed. Okay, these guys are like the high speed MPO connectors, which are dedicated and designed specifically for AI and machine learning operations. What does it stand for? Multiple fiber push on. This guy right here. Then comes the patch panel, which is very interesting. This piece of equipment actually is the organizer of the cables. I will just put it this way. This is the command center of your networking cables. Whether we're talking about copper or fiber connections, this is where everything comes together, making it easy to keep things neat and mainly organized. So for fiber optic networks, patch panels are a lifesaver when it comes to managing and quickly connecting equipment, especially when cables are running in from other racks. Let's just take a look here at the Cisco Fiber patch panel, this guy right here. Just, it takes it up to the next level. Why? Because this panel will enable you to facilitate breakout connectivity from, let's say, 400 gigabit per second to 4 times 100 gigabit per second. What does it mean? I mean, if from one end you're trying to just connect a 400 gigabit per second cable, and then from the other hand you want to just receive, or like I should say, break this down into 4 times 100 gigabit per second cables from the other end. This is going to be your best friend. Okay, so how's this going to work? Well, just take a look here at the different features of this 2-rack unit patch panel. I mean, you can read it yourself. The mounting brackets, the cable hanger arm, the tray identifiers with labels, the panel door locking mechanism, and lots of features in here that make this a top-notch equipment that you need in your AI-enabled data center. Not just, this is the front view. What about the rear view right here? Okay, well, here we go. A 2-rack unit panel has 36 rear MPO12 ports. 32, where's that number? Oh, 36 rear MPO12 ports. That's one magnificent feature within this patch panel. With a one-to-one mapping to the 36-port line card. It's a one-to-one mapping. Okay, that's quite magnificent when it comes to creating those kind of connectivity or organization between the cables in different racks. Another example here, if you look at the 400 gigabit per second to 4 times 100 gigabit per second breakout, this is going to help you. I know that you've been waiting for this diagram because you want to imagine how this actually happened. The front breakout module right here, this guy supports a 400 gigabit per second 12F MPO. This guy right here, this is a single 400 gigabit per second, which is mapped to 4 100 gigabit per second of LC breakout connectors, well, which is going to be very beneficial when it comes to, let's see these guys here, when it comes to Cisco Nexus 9000 series switches that come with 400 gigabit per second ports that you need to connect to another Cisco Nexus 9000 series switch, but that supports the 100 gigabit per second bandwidth. Using the MPO to MPO cables and the LC SMF cable right here, and also the QDD form factors. These are very helpful for these kind of scenarios. And let's not forget, if you want to just, go for some kind of cables like the DAC cable, this guy right here, the DAC. Well, what's that, by the way? This is an example of a cable with QSFP connectors on both sides of the cable, which is also known as the direct attached cable, DAC. And on the other end, this guy right here, take a closer look, because this is the breakout cable that we were talking about. Here we have a 4-lane 100 gigabit per second port that can be split into 4 times of a 25 gigabit per second connections. Let's not forget about InfiniBand as well. It also has cables, definitely, and it plays a major role. Those cables play major roles in the performance of the InfiniBand technology itself. So using a unique multi-lane design, which comes as a single link, or maybe you can have 4 links or 12 links, this allows those cables to handle more data simultaneously, available in copper or fiber optics as you need. These cables have evolved from the early single data rate SDR, and it evolved, and now we can find them in extended data rate XDR. Okay, well, that's cool. But when it comes to latency, both InfiniBand and Ethernet, they're quite similar. So both add around 5 nanosecond per meter. But hey, what sets them apart is the kind of connectors being used. When it comes to InfiniBand, the modern InfiniBand setup, they often use the QSFP or the OSFP. Okay, with the OSFP mainly, which is designed for high speed and seamless upgrades from 400 gigabit per second to 800 gigabit per second. And of course, InfiniBand is nothing different from Ethernet when it comes to the breakout cables, just like this guy right here. So if you want to break out a cable of a specific speed or specific bandwidth to several smaller ones, this is also doable, making it easy to connect those switches and endpoints together if you have discrepancy between the speeds and the ports. Let's summarize really quick. So we have 2 main technology when it comes to AI-enabled data center, Ethernet and InfiniBand, both of which provide different cables and different media types, copper and fiber. Of course, that depends on the bandwidth that you need. Let's not forget the patch panels as well, which provide a way to keep large numbers of cables organized. I hope that this was informative. I'd like to thank you for viewing.